Today's webinar, Cleaning Up the Problem, What to Do When Experiencing Color Streaking, Degradation, and Contamination, is brought to you today by Dyna-Purge. Your presenter today is Nancy Mitchell, Technical Product Manager for Dyna-Purge, a division of Schumann Plastics. Mrs. Mitchell joined the Dyna-Purge team back in October 2007 and is responsible for all research and development. Her background experience includes management of multifunctional work teams, direct coating operations, quality assurance, and plant management. In the past 6 years, Mrs. Mitchell has worked extensively with plastic processors around the world, developing 5 new products during that time. She is the author and co-author of 30 patents and has written numerous technical articles on the topic of purging. Mrs. Mitchell has a BS in chemistry from Lake Erie College and completed the executive training program at Kellogg Graduate School of Management, Northwestern University. She is also certified as a pro molder by the Paulson School of Molding. My name is Trey McDonald with UL, and I'll be moderating the event. Now I'd like to turn the presentation over to Nancy. Nancy?
Thank you to ULIs, and hello to all of you. I really appreciate the opportunity to speak with you today, and truly hope that you'll find our presentation to be of help. To start, we thought it would be beneficial to provide you with a very brief history of purging. Back in the early 1980s, Dyna-Purge, along with another company, pioneered the use of commercial purging products. Since then, over 100 companies have entered the market supplying mechanical, chemical, or hybrid commercial purging products. To better understand the size and scope of the market, a few years ago, Plastics News commissioned a study asking plastic processors if they use a commercial purging product. To the surprise of many, over 80% of you responded with a yes. When asked the question, which factors do you consider when selecting a commercial purging product, 93% said product performance, 62% product is easy to use, and 50% said safety of using products. Rounding out the top 5 were also free samples and lowest price. More recently, in August of this year, Plastic News commissioned an independent study with Signet Research. They surveyed approximately 9,000 processors, asking them one primary question: who is your top supplier for purging products? Dyna-Purge was ranked number 1 at 56%, OxiClean was number 2 at 41%, Rapid Purge at 32%, Purgex 18%, and Easy Purge was ranked number 5 at 17%. As the purging market continues to evolve, so does the appetite for learning. Earlier in the year, we polled our own customers, asking them to, first, please identify one or more of their most difficult purging-related issues, and second, please identify one or more of their current business challenges. The majority of responses led to 4 common themes and identified a clear need for more conversation on these issues. So as a leader in the market, we decided to sponsor a 4-part webinar series under the headline, From the Boardroom to the Shop Floor, Answers to Your Top Questions. Working in collaboration with ULIs, we sought out the most recognized experts in their respective fields and came up with the following. The first webinar, How to Find and Keep the Right People, was co-sponsored with Plastics Today and was initially launched as a live presentation at the Plastic Midwest show back in September. The presenter, Dr. Russ Rindeau, is an expert on recruiting the very best talent. Dr. Rindeau's presentation covered all the important aspects of how to find and keep the right people. To date, his presentation has been uploaded over 550 times from the ULI's website. The next webinar was on the topic of training and how training can lead to sustainable changes and improvements in a plant. The presenter was Andy Rootsis of Rootsis Training, the premier leader in plastics training. Mr. Rootsis discussed the shortage of qualified technicians in the world and why training is such an integral part of improving the bottom line. The webinar was very insightful, and as of last month, approximately 400 people have seen the presentation. The third webinar was held just last month, and the presenter was John Bizzelli, one of the most recognized experts in injection molding. Over 500 people registered for Mr. Bizzelli's presentation. He addressed, among other things, how a poorly designed screw and barrel can be a major culprit and experience a lot of degradation, high levels of scrap, and extensive downtime. So here we are today, the last presentation in our 4-part series, Cleaning Up the Problem, what to do when experiencing color streaking, degradation, and contamination. Before we get started, please don't hesitate to submit questions during today's presentation. We will do our best to answer all of your questions at the end. While there have been other purging webinars on issues such as color changes or purging through hot runners, none have addressed what the most common problems are when purging. All too often, purge products are not used properly or in the most cost-effective manner. We hope today's webinar will provide you with some insight on what the most common problems are and, more importantly, how you can overcome them. So let's begin by identifying what the 3 most common issues are. First, we will cover why selecting the right purge product is essential for a successful outcome. There are a lot of different brands and grades on the market. It is our experience that many times the wrong product is being used, or better stated, the very best product isn't being used. Today's webinar will break down why that happens, along with offering an in-depth review on how to select the best product for your needs. Next, we will address how, even if you are using the best purge product, your results can still be disastrous if you aren't following the best procedure. Selecting the right procedure is just as important as selecting the right product. We will share with you why, at times, the wrong procedure is being used and how easy it is to implement the best procedure for your equipment. Then finally, we will explore the high cost of scrap and lost production time associated with purging. Creating the proper tools for tracking and monitoring your purging program will go a long way in solving the problem. We will share with you some simple measurement tools you can use during initial trials and on an ongoing basis, and that will help you achieve the desired results you need. Okay, we already have some great questions coming in. So let's get started with the first section pertaining to the most common problems when purging and how to select the best product for your application. There have been a lot of advancements made with purge products in the last few years. While both mechanical and chemical-based products offer general purpose grades, there are also a number of grades that have been designed for specific applications. Selecting the very best product for your application is essential for a successful outcome. In order to make a decision on which product is best for you, the first question that needs to be answered is, what resins are you running? Understanding the intrinsic properties of your production resin is very important in determining which product is best for your application. Therefore, we are going to discuss how such things as processing temperatures, thermal and moisture stability, viscosity, color, and clarity will help in understanding which purge product is right for you. From there, we will review how additives can be a major factor in how aggressive the purge products need to be. Finally, we'll explore the type of equipment you are running, specifically the use of hot runners. Whether you are planning on using a mechanical or chemical-based purge product, knowing the processing temperatures of the production resin is a critical factor in selecting the proper grade. For example, using a purge product that is designed for a low temperature will not work well in a high temperature application. A higher temperature will radically change the velocity profile of the purge material and therefore will leave too much resin behind. As you can see on this diagram, the purge is flowing much too quickly and has carved out a tunnel through the resin. As a result, the production resin remains behind on the channel surface. This leads to color streaking and degradation. Processing temperatures vary widely among resins. It is important to match the purge product to the resin's processing temperature. In some cases, such as with high temperature engineering resins, we also recommend operating at the lower end of the range to maintain a higher viscosity purge for maximum efficiency. Now let's discuss thermal and moisture stability of a resin. Heat and/or moisture-sensitive resins such as PVC, nylon, and polycarbonates degrade much faster and therefore may lead to carbon buildup, which can result in black specking. When experiencing black specking, a more aggressive purge product is required to scrub the carbon buildup from the surfaces of the screw and barrel. Examples of aggressive ingredients would be fillers, such as acrylic, glass, talc, and calcium carbonate. However, some of those ingredients may be too abrasive. For example, while acrylic will soften and not damage the metal surface, glass can cause damage over time. Also, when shutting down your machine, it is imperative to remove any unstable resins since they tend to degrade. Check with your supplier, but most have a product available for shutting down. Another key parameter to understand in selecting the right purge product for your application is the viscosity of your production resin. Viscosity is a measure of a resin's resistance to flow. Melt flow indexing is the most popular way to determine the viscosity of a resin. Although not entirely accurate in predicting all flow characteristics, melt flow values can be used for rough comparisons between materials, and they are readily available from resin suppliers. A higher melt flow indicates a lower viscosity. Since purge products work with physical force and agitation, the melt flow of the resinant resin will have an impact on the product's effectiveness. A low melt flow resin requires a stiffer purge product. While stiffer products work well for purging a broad range of resins, in some cases it is difficult to displace them with the next production resin. This step is referred to as post-purging. If you are running a higher melt flow resin, a purge product with a higher melt flow should post-purge more effectively. If, however, you are running a resin with a very high melt flow, for example, for a thin wall medical part, you will likely have a problem post-purging. In a situation like this, most suppliers recommend running a blend with a natural resin to decrease the overall viscosity of the purge product. Now let's talk about color and clarity. First, color is simply the #1 reason for purging. The advantages of using a commercial purging product from a dark to a light color are well documented. However, as many of you have already experienced, there are some colors, even light colors, that are more problematic to purge than others. Why? Well, there are a wide variety of pigments and dyes used in the plastics industry. In particular, liquid colorants and organic pigments are difficult to purge. Some of these additives have an affinity to metal and require a more aggressive purge for cleaning. In addition, if using color concentrate, please know that some of the carrier resins, such as EVA, will thermally degrade if left in the barrel too long. With respect to clarity, when running parts for automotive, medical, housewares, etc., there can be no impurities. In this case, it is important to match the right purge product to the right base resin being run. For instance, an olefin-based purge product may cause cloudiness in a clear acrylic or polycarbonate part due to the incompatibility of the resins based on their chemical makeup. Use of the right product will make the changeover much faster and create much less scrap. Check with both your resin and purge suppliers to make sure you have the right product for your application. There are numerous additives used in plastics today, and many of these can impact the selection of a purge product. For example, flame retardants break down endothermically when subjected to high temperatures, leaving residue behind. If your purge product is not effective in removing these additives, you may end up with carbon buildup, which becomes much more difficult to remove as time goes on. Periodic purging to get rid of buildup ultimately helps eliminate contamination and may extend the life of the screw. More recently, fiber-reinforced plastics are gaining greater acceptance, particularly in the replacement of metal parts. These glass and carbon-filled resins are stiffer and more difficult to displace than unfilled resins. Consequently, they require a purge with a lower melt flow. When purging an injection molding machine, most of the emphasis is on the barrel and screw. However, for today's discussion, we will focus on hot runners. There are many things to consider when purging through hot runners. Many hot runners have tight clearances. Channels may be poorly designed or have uneven temperature profiles. They may be balanced or unbalanced. In such cases, it is important to use a purge product that flows evenly through the manifold, tips, and gates and expands into the negative flow areas. Recently, there has been some discussion on whether or not you can make a part with a purge product. While this can be a much slower process than purging with the mold open, in some cases, it's the only way to purge through the hot runners. While some machinery adjustments may be required, most purge products can be molded. We would encourage you to check with your supplier for additional information. Whether purging with the mold open or making parts, there are a number of purge products on the market that are designed specifically to meet the challenges of hot runner applications. By most accounts, this is one of the fastest growing areas for purge products today. Okay, keep those questions coming in. Now let's move on to the importance of establishing the right purging procedure. While there have been plenty of advancements in the development of new purge products, there have been just as many improvements in how these products are used. In this section, we will review why selecting the right procedure is just as important as selecting the right product. Over the years, we've spent a lot of time working with our customers developing new procedures to improve changeover times and reduce costs. If a processor is having a problem with their purging procedure, the answer can usually be found in one or more of the following questions. 1, are you using an old procedure? 2, has your application changed? 3, are all of your operators following the same procedure? Or 4, have you modified the procedure to enhance results? Since we are all creatures of habit, too often we find ourselves following old methods and procedures. We would encourage you to check with your purge supplier to make sure you have the latest and greatest procedure. Every major supplier periodically updates their procedures as part of a continuous improvement program. A case in point, we worked with a Tier 1 company implementing our quick color change procedure for transitioning from a dark to a light color. The old procedure was to finish the run, back off the barrel, and then starve the machine of the resident resin. From there, you would introduce the purge and continue to purge until the equipment was clean and free of contamination. The procedure would then address purging through the hot runners. However, this 12-step procedure was too time-consuming for this Tier 1 company. We then introduced the quick color change procedure, which is a continuous process and eliminates starving the screw of the resident resin. In this particular situation, our customer saved over 30 pounds of good material by no longer starving the screw. In addition, by utilizing Dyna-Purge more efficiently, they used approximately 30% less purge. In the end, this new procedure entailed only 6 steps, saving our customer material, time, and a lot of money. A procedure that works well for one application may not work well for another. There are many examples of this. Recently, we were approached by a custom molder who was having a problem with a new job they were running. They had been running an HDPE job making food containers. They picked up a new job running PVC appliance panels and decided to run it on the same press. They began to experience black specking on Monday morning after weekend shutdown and ended up with a lot of scrap. We introduced them to a new shutdown startup procedure that prevented PVC degradation and eliminated the black specks. In the shutdown startup procedure, the PVC was purged from the machine and replaced with a thermally stable purge product. In addition to purging, this grate also shrinks while cooling, pulling the remaining contamination from the metal surfaces of the screw and barrel. It is quite common for different operators to use different procedures based on their previous experience. Variations among shifts can be quite significant. Some operators have developed best practices, while others might be following old, outdated procedures. Whatever purging procedure your company decides to implement per machine, tool, etc., it should be the same procedure for all operators. The best way to promote adoption of standardized procedures among operators is to implement a training program. A successful training program should be customized for your plant. There are many excellent consultants who can help you customize a training program for your company. One such training solution called Right Start was discussed in the second webinar with Andy Woutsis. We at Dyna-Purge have also been involved in establishing specific training programs for purging. One such example was a Tier 1 automotive customer that wanted us to establish a training program on purging for their new hires. In addition to creating a customized training manual, we also gave them access to our website, where we have training videos in both English and Spanish for every procedure. While every purging supplier has spent a lot of time perfecting their recommended purging procedures, the truth is there are times when modifying them will improve the results. That is why suppliers like Dyna-Purge have created a performance tips section on their website. There are so many variables to take into consideration when establishing a procedure. While in most situations a standard procedure will work well, at times modifying it may enhance the results. As examples, one machine may have a problem with material getting hung up in the check ring. In this case, more high-velocity short shots will loosen the contamination, whereas another improvement may be associated with purging through valve-gated systems. If some of the channels are more problematic due to poor design or wear, you may have to close off certain gates and redirect more purging material to the difficult channels. The point is, once you validate these modifications and best practices, make sure they become part of the new procedure. Okay, now that we have covered selecting the right product and using the best procedure for your equipment, we have arrived at the last section. Are we properly measuring and tracking the results from purging? In order to properly measure and track purging, you need to know what the real costs are. Every purging supplier has on their website a cost to purge calculator. Regardless of whose cost calculator you use, there are three basic components that define the real cost of purging. They are material. This is both the production resin and purging material. Downtime. This is everything from purging time, including soaking if you are using a chemical product, to the amount of time it takes to post-purge. And scrapped parts. This is the number of bad parts made after purging and before a good part is made, capturing both time and material. We refer to ours as a savings calculator. Here's an actual example recently completed by a large producer of polypropylene chairs. The changeover was from blue to natural, one of their more difficult transitions. It normally took 2 hours to complete the changeover using 190 kilograms of natural resin. With Dyna-Purge, the changeover took only 52 minutes and only 44 kilograms of material is needed. A savings of $285 per purge was realized. This translated to over $41,000 in savings annually for just the one press, and demonstrates the value of measuring and tracking your process in order to make the best decisions about purging. Although some of you might find this a little surprising, purging is usually an emotional experience. The degree of subjectivity when running purging trials can be quite significant, even among different operators within a given plant. The importance of properly measuring your purging results from the outset takes on extra meaning when you understand this. The more science applied to managing your purging program, especially during the trialing stage, the better off you will be in the long run. It is fascinating to see the different means used for introducing a purging product into a machine. While the most common methods would be a scoop, bucket, or vacuum drawn, we have seen everything, including the use of coffee cups. For some companies, this is not a big issue, but for others, there can be a significant cost for not properly measuring purging consumption. How does your company measure usage? Once you have established a real cost to purge and a good method for measuring usage, how are you going to track the results? Control charts are one of the most commonly used methods of monitoring the stability of a process. They visually display the fluctuations of a particular variable, such as scrap, in a way that lets you easily determine whether these variations fall within the process limits. They let you know if you are continually improving or if you're having a problem. One thing that concerns us is when we see a customer is using too much purge product. That is when we worry that a purging process might be out of control and we would like to step in to help. For instance, on this chart, you can see when the heater bands broke. You can also see the downward trend in scrap when a new purge procedure was implemented. So let's leave you with some thoughts to consider. If you are dealing with color streaking, contamination, and degradation, our message to you is to stop purging and start planning. It is imperative that your plan addresses the three key components, which are selecting the right purging product, implementing the best procedure, and measuring and tracking results. In the first section, we reviewed how to determine if you have the best product for your application. There are a variety of purging products offered in today's marketplace, ranging from general purpose to specialty grades. Selecting the correct grade is the first step in assuring a positive outcome. Next, make sure you are using the very best procedure for your purge product. Even if you are an existing user, you might not be following the most cost-effective procedure for your application. Then in the third section, we discussed how to measure and track your purging results. As we covered in today's webinar, there are some simple steps you can take to measure and track performance. With the proper tracking documentation, it is much easier to show the benefits of using a purge product. It is also a very effective tool in assuring consistent results on a day-in and day-out basis. In closing, this presentation will be available to download from the ULI's website. We would also like to extend our personal services by letting you know that Dyna-Purge will be glad to assist you with implementing an effective purging program. On behalf of all of us at Dyna-Purge, we want to thank the other presenters, Dr. Russ Rendell, Andy Routsis, and John Bazzelli. We also want to thank you for taking the time to be with us. We hope you found the webinar series beneficial. Now, let's spend some time answering your questions.
Okay, first question. How can I know how much material to use during the quick color change procedure? Do I have to pre-measure the purge? Great question. The answer is yes. The amount to use is usually 1 to 2 times barrel capacity, but you really need to run trials to determine more precisely the amount that you need for each machine tool configuration. We can work with you to narrow it down and ultimately reduce the amount. The quick color change is best in environments like automotive, where you're doing the same types of color changes day in and day out, but the savings can be significant. Next question. I run a variety of resins with a wide temperature range, so for me it is hard to pick out just one product. Do you have any suggestions on how to narrow it in? Maybe to just 2. This is a really common question. We would assess all of your applications to pick a product that would cover the most. In a lot of cases, one purge will cover a pretty wide temperature range. For example, Dyna-Purge M, it's our most popular and versatile grade. It's used in a variety of applications, and it operates from 350 to 600 degrees Fahrenheit. Then we'd identify any specialty areas like for clear applications or high temperature engineering resins, and we'd recommend a second grade if it was necessary. You can contact your Dyna-Purge rep or send in an inquiry to our website, and someone will get back to you in 24 hours. You can also visit our selection guide on our website, and that'll give you an idea of what's available in different temperature ranges. Next question. I am running fiber-reinforced plastics at high temperature. I also have tight clearances, so is there anything on the market that I can safely use? Reinforced plastics require a very aggressive scrubbing grade. Dyna-Purge E2 is our high temperature grade, and it's very aggressive. It's also thermally stable and can be used from 575 to 715 degrees Fahrenheit. It can go safely through hot runners, even with tight clearances. We also have a series of tips to help with high temperature purging. For instance, along with the big resin suppliers like BASF, SABIC, and Solvay, we recommend purging at the lower end of the processing range. You get better purging, and it's safer for operators. You can find other tips on our website under the Performance Tips section. Okay, next question. Are you planning on doing any future webinars? If so, how can I share my webinar ideas with you? Yes, we are planning on future webinars, and we'd appreciate hearing your ideas. Please email me. It's nmitchell@dynapurge.com, and please put webinar in the subject line. We will be sending out surveys in the next couple of months and would encourage everyone to let us know what topics you think would be good. Then we'll compile all the results and pick the top candidates for 2014. We'll also let you know if your idea is picked. Next question. I have a difficult phthalo blue color change. Any tips for that? Good question. Phthalos are one of the hardest colors to purge because they have that affinity for metal. You need to use a very aggressive purge like our Dyna-Purge M. Some tips at the machine: you can increase back pressure. That increases agitation. You can increase the temperature. Pigmented resin then becomes more fluid, and it's easier to push out. Or you can try jogging the screw, alternating the RPMs up and down. Short bursts at high speed increases the agitation. Then when you decrease the speed, that allows the purge to expand into all the areas. So it's catching all the pigment when you ramp the speed back up again. Next question. I'm going to try a cost calculator. My old method was to purge with regrind mixed with a chemical. So in the first step, do I measure the regrind and the chemical? Do I have to count the time in too? We pre-mix it ahead of time. Yes, all time associated with the purging process should be included, and that includes pre-mixing, it includes soaking for chemical purges, also includes any machine adjustments you might be making. So for instance, if you're raising your temperature and then lowering it again, you should include that time. Next question, what is the best Dyna-Purge grade for polyolefins? Well, polyethylenes and polypros are the top resins used in the plastics industry today, and we have a number of grades that are suitable for them. We would base the selection, of course, on your application. But a good example is Dyna-Purge F, which is used very extensively with polyolefins, especially for color changes. Next question. What grade do you recommend for hot runners, and what's the minimal clearance? Most hot runners have a minimal clearance of 25 thou. We have a variety of grades that will meet this clearance restriction, and in fact, some of our grades like F, C, and E2 have no clearance restrictions at all. But of course, we would recommend a grade based on your particular application. Your Dyna-Purge rep can work with you to determine the best grade for you. Next question, what can I do with the purge scrap? Well, three things. You could dispose of it in the same way that you dispose of your regular resins. Secondly, you could resell it to scrap dealers. That's the most popular method, especially with the large users. And thirdly, in some limited cases, you can actually regrind the purge and reuse it in your parts at low levels. But some grades lend themselves to this better than others, so you need to check with your Dyna-Purge rep to find out which grades would be best for you. I'd also like to mention that we've introduced a new product called Lava Shield. It's a protective purge guard. It has quick release properties, so you can actually purge onto it, and then after it cools, the purge patties slip right off. They stay clean that way, and they can be sold or reused. Next question, does Dyna-Purge have a product for clear applications? Yes. If it's clear acrylic, polycarb, polystyrene, PET, etc., then C is a great product. It was developed specifically for those types of applications. The base resin's compatible, and there's no cloudy residue. It's pretty versatile, too, and it's okay with hot runners and screens. On the other hand, if your clear application is a polyolefin, then F is the best grade. It's great with polyolefins, and there's very low residue in the post-purge. Next question, can I mix the purge with something else? Well, actually, no, we don't recommend that. Dyna-Purge comes as a complete product. There's a dilution effect, so it doesn't purge as well if you mix it, and it takes more time. On the other hand, you can mix it for post-purge. As I mentioned before in the presentation, if you have a high melt resin, it could be a good intermediate step and help with the post-purge process. Next question. How do you recommend we measure our usage? Right now, we just estimate it. Well, of course, at the plant level, you can track purchases. One of our customers, or a number of our customers actually, keep a log where the purge is located. Anytime a purge is taken, the amount is recorded, and the operator and the machine are recorded as well. At the press, the best way is to weigh it, and then you can kind of standardize the delivery method for each application. For instance, a bucket or a scoop or a cup. A lot of our customers also record the amount as well as the procedure, and then they laminate it and hang it right at the press so all the operators can see it. Another way is to weigh and track purge patties. But once you've set up a system, the important point is to keep tracking it so you can see if there are any problems along the way or if any improvements are being made. That looks like all the questions we have time for now. Thank you, everyone, for your participation. I'd like to pass it back to you now, Trey.
Thanks, Nancy. Again, thank you, everybody, for attending today, and have a great rest of the day.